Hi, so my name is John Engelman. I'm going to be talking about bootstrapping your continuous integration and deployment for your organization. I'm a chief technologist for a consulting company called Object Partners in Minnesota. For the last 3 years, I've been focusing mostly on doing DevOps and build automation and deployment automation for our company. I'm a core team member to the Rat Pack framework, if you've seen that. I'm also the author of the Shadow plugin for Gradle, which is out there. It's kind of a big plugin used to generate fat jars, bundle up all your dependencies. I'm at John R. Engelman on Twitter. If you ever want to follow me, I'm the same name on GitHub. And R is my middle initial because there's another famous person with my exact same name that tends to come up in search results. Also, this is a sea lion from the last time I was out here speaking at Gradle Summit that I got to take. So I just thought that was kind of a cool picture. So what is bootstrapping and what do I mean when I say that in this kind of scenario? We're not talking about this, but what we're really trying to get to is how do we go from 0 to 60 in 4.4 seconds? And what I mean by that is, how do we get our developers up and running as fast as we possibly can? How can we beat that learning curve? How can we get them into a Gradle ecosystem and an automated build environment without them having to learn all the intricacies of these tools, right? How can we just give them something that does what they expect it to do? I picked that 4.4 seconds because that's the 0 to 60 time for a Ford Shelby GT500. We also want to provide a consistent and sane set of configurations for our developers, right? I mean, as your organizations grow and you add more people, when you go from 5 developers to 20 developers to hundreds to thousands of developers, we need to have some kind of standard around how these things will work. Everyone tends to do things a little differently, right? So if we just let each team implement their own set, which is one way to totally do it. I'm not saying that's wrong, but when you allow teams to do that, you're going to get different implementations of those sets, and they might end up being the resulting end way, but it kind of makes transition from team to team a little bit more difficult. And finally, we want to ensure that the important things as deemed by our company or our organization are always there, right? If we always want to have Java docs published or source jars published, we want to ensure that that's going to happen regardless of however you've set up your build. So kind of from a picture standpoint, what we're looking at this, we have all these core and third-party plugins in Gradle that are built around providing specific sets of functionality, right? We have the Java plugin, the Groovy plugin, all these plugins that do specific things to your build. But what we really need then is something that's going to tie together these different feature plugins with our organization rules and organizations or conventions, and then enforce that across all these plugins, right? So we end up with writing our own kind of custom thin plugins that either apply these plugins or react to them being inside of your build and then enforce these sets of rules and conventions. So how do we start doing this and where do we start from? A great way to start proving out a lot of these concepts is just by writing script plugins inside of your build. So Gradle, if you're new to Gradle, you can write custom Gradle plugins just inside of a script inside of your build and apply them. So you don't have to have an entire infrastructure set up where you're building a jar and publishing it and putting it on a portal and resolving it from there. You can extract pieces of logic out of a build into a separate file so that you can reuse that. And you can either provide that on disk or you could potentially pull that in from some hosted location. This allows you to quickly try new settings because these script plugins are actually evaluated as part of your build on every build. So you don't have to recompile them. The Gradle runtime engine is just gonna, slurp that up and apply it to your build every time. Again, you can just host these on any type of web server that you can just resolve from. So you don't need some big infrastructure to do it. But if you need to, when you get these more advanced, you can go into building a true Gradle binary plugin that you package up as a jar and distribute as a normal artifact. And the reasons why you would do this and go forward with this is if you find yourself in situations where you need to do more than just using the Gradle DSL to apply conventions. We'll see some examples of that, but the primary one is if I want to have a set of additional resources, whether they're template files of some kind or things like that I want to package up into this jar and distribute them all together so that they're all part of the same version. You would go to this level then where you're actually building up an artifact. One of the great places to look for information about this stuff is the Nebula plugins. This is Netflix's build language, which they'll be talking about later today, I think, right? Yep. So these plugins are all kind of built around these same concepts of how do they go about applying this kind of common build infrastructure across a bunch of projects at Netflix. And these are available out on GitHub. They're a great resource to look at and kind of just read through the code and see how they're adding these features to people and how they can be reused in kind of a composition manner to pull things together. There's a lot of good stuff there. There's a test kit for testing plugins. There's a lot of release and versioning type plugins. Those are all really, really good ones to look at. So what are some of the good things to Bootstrap? Versioning is one. That's kind of a problem that's usually set by your organization, right? You have some type of policy about how do we do versions or how do we version our code as it comes out. So there's a lot of different kind of styles for doing this. Traditionally in like a Maven build, you would have, you specify your version right in your build file, and on release you increment that and so on. Some of the newer things are, do you read this perhaps from an external file so it's not coupled into your build logic and it's easier to parse and handle? Or do you rely on your version control to actually provide this? So you could do things like inspect the commit that you're checking out and use that as part of your version, or you could actually look at tags inside of your repository to determine your version, and you can infer it from where you are inside of your version control. IDE integration, if your organization has, if you use the same IDE across everything, or maybe you have a variety of IDEs. Some people use Eclipse, some people use IDEA. Perhaps you want to just enable that integration in all your builds by default, and there could be some special settings that you want to provide. Like in IntelliJ, you need to tell it the JDK language, and you can configure aspects of the IDE integration right there with your Gradle build. So if you know how that's going to be, then you can just pre-populate that for people so that as soon as they check out this repo and import it into their IDE of choice, they get a running and configured environment right then. Another great piece to configure is dependency repositories. If you're in a private organization and you have your own Artifactory server or Nexus or whatever, maybe you pre-configure that as a location for dependency resolution for all of your builds. A lot of organizations, maybe they don't have an open repository, so you need to provide credentials, or you need an online or an offline URL, depending on if you're like inside the network or outside the network. And you can pre-configure all of that. On the flip side, you can even just say, well, we're going to add JCenter or Maven Central as the first location, and then people don't have to think about adding those repositories later. They can just focus on the important parts, which is what dependencies do I need, and not necessarily where they come from. Testing and static analysis. If you, Ben was talking previously in the previous talk about kind of build pipelines and how you set those up. And part of that is perhaps defining a separate integration test phase over your unit test phase and a functional test phase. So if you have a paradigm for that you want to enforce across your organization, you can pre-configure those, create those tasks and pre-configure them with where their sources are going to come from and how they're going to execute for the projects. Static analysis is an interesting one because you have things like find bugs or code narc or check style, and those are all very heavily configurable about what rules do I want to follow or what rules, or which ones do I want to ignore. So how do we as an organization then, we can bootstrap in those sets of rules so that every project is following the same sets of rules. One of the, if you get into an organization and you don't do things like this, you'll often just see people, oh, like, I'm failing these code narc rules, and so the first thing they'll do is they'll just disable them, right? Happens a lot of time, like your test code, things like that. So if you don't want them doing that because you want to enforce that strictness, then you can override any behavior that they're trying to put into their build this way. Artifacts and publishing, I kind of alluded to earlier. So if every one of your builds has a jar, but then you also want to ensure that you're publishing a Java doc and a source, or if you're bundling up your application as an actual distribution, so you want to package a fat jar or an Uber jar that has everything in it, so that some downstream system, when it deploys, it doesn't have to care about dependency resolution. It can just pull that fat jar and run it with the Java command. You can pre-configure all of this for your builds, regardless of whatever they actually end up putting in there. And you can configure where your repository locations are, and you can configure how do you get credentials to publish into that. These are kind of concepts that, as a developer, you would never care about on a day-to-day on your daily job, because you just want to write your code, test your code, and have it build and available for deployment, right? And then I've mentioned credentials a couple times here. There's some other things that you might bootstrap, and I underline might here because you can go down this road, but sometimes you can overdo it, right? You can end up bootstrapping too much information into your build, and you end up masking what's actually happening to developers. Racking my brain, I could only come up with one really good example from my experience in doing this, is adding common library versions to builds. So if you have a plugin and you're adding the Groovy library or Spock and to your test scope and all these things, like you can get very out of control very fast if you start adding, well, we're going to add Joda time, or we're going to add H2 for database, for in-memory database testing, and it just kind of goes down the line and can spiral out of control. And what happens is then as a developer, when I'm building this application, that's not really clear to me unless I'm looking at those dependency reports. So if I try to add something, if I bring in Hibernate or whatever, it just kind of, there's too much magic happening. So you want to be careful about some of these, of how much you're going to add and how much you're going to hide away from the developer in their builds. The Gradle project DSL. So this is the key to writing any type of plugin. Whether you're writing a full-fledged feature plugin that's going to be out in the portal, or you're just writing one of these thin wrappers like I'm talking about, you need to read the DSL, you need to understand it, and you need to use it. There's a lot of powerful concepts inside of there that make this kind of authoring very easy. And which, if the authoring is easy, then the maintenance is going to be easy. And if you want to add additional features, it's not going to impede your work. You don't have to spend a bunch of time adding new capabilities if you just understand how this is going to work. A couple of the key pieces out of there is to make liberal use of the plugin container. So I should have put a star next to this because some of these ideas and pieces of code that I'm going to show you here in a little bit might go away with the new configuration model and stuff. You know, we're going to all have to kind of relearn what best practices are once that's in the mainstream. So the reason why I say make liberal use of the plugin container is because it allows you to react to the presence of other plugins instead of declaratively saying, you know, apply all these plugins. Instead, I can say, here's my company's plugin, and here's the conventions for if you also have the Java plugin installed. So I don't have to enforce that you put the Java plugin in, but I can just react to the fact that you've added that additionally into your build, and then I can configure your build for you. So there's a couple methods on the plugin container that allows you to do this. There's a with type that takes a class, and then there's a with ID that takes the plugin string ID. And what these really do is the plugin container is it's a named domain object container. You can effectively think of it as a live backed list of the plugins that are in the project. And when you call one of these methods, you're actually registering an action with that container, with that list. And that action will be fired at any point that a plugin enters. Yeah, question?
Question is whether the order of plugin application is important for such constructs.
Yeah, so the question was if ordering, or maybe comment, is that ordering of these things can still be important. Yes and no. It's kind of a two-part in that if you're just declaring that I apply these plugins, you're ensured that those features are going to be there for you, right? Doing it this way, though, also allows you to kind of defer some of that configuration, so that order doesn't necessarily matter inside of your build file either, because I'm not going to try and like we'll take the bottom one for example. So if you've added the shadow plugin to your code, then I'm going to configure it. That action's not going to fire until after the shadow plugin has been applied and executed all of its configuration. So you can be ensured, you can be certain that by the time my action fires, anything that the shadow plugin has added will be available to you to configure at that point. So it does let you kind of mix and match and change up the order of how plugins are installed. That's something to be really careful about if you're going to be a good plugin author in Gradle, is that you have to check for those kinds of things. You can't just assume that they're going to be there, because you can blow up people's builds that way. Yeah. Another good use is to make use of the extra properties inside of your Gradle build. The project, and actually most tasks by default have this extra, this ext variable that allows you during the configuration of the build script, you can inject properties or methods onto these objects. So you can extend a task or a project with additional information. So these are just a couple of examples of what I normally add into kind of our base project plugins that we apply everywhere. Is, you know, can we add a flag that tells us if we're building an integration version versus an actual release version. If we're on our CI system, we can inject in some metadata or just to indicate to us that we are on our CI system as opposed to a developer's machine. So you can make decisions then later in your build and use these flags to trigger different behavior. Perhaps you have a set of tasks like, say your application is going to additionally build a Docker container that you want to deploy later. On a developer's machine, that you probably don't need to do that because they're not going to be running that Docker container. They're just more concerned about the code and the tests. But you don't want to tell your CI system that it needs to additionally run all these other tasks, right? You just want to declare that build Docker image as part of your build task. So what you can do is you can use one of these flags then, and you can set that task to only run if that flag is enabled on that trip. So if you would run it locally on your machine, that task, that build Docker task, would just be skipped over every time because you're not on a CI system. Templating standard files. We do this a lot with CodeNarc is a good example. You would do this if you have the situation where you're using a plugin or you're doing something that actually needs a physical file on the disk. The CodeNarc plugin requires that. You can't just like give it a stream of stuff. So what we do is we bundle in our template of CodeNarc, our CodeNarc.groovy file, and we have a task inside of the plugin when we apply our kind of standard CodeNarc plugin, which is actually just a response to if you have the Groovy plugin in your build. So if you've applied Groovy, then we automatically configure CodeNarc for you. So we can go into our jar file that has our plugin in it and has this resource bundled in, and we can write that out into a location in your workspace in your project, and then we can use that as the source for the CodeNarc test when it runs. You can also extend this to what we do is we do it only if you don't have that file. So it does allow you to make then changes to it. So project by project, someone could enable or disable rules, but you could easily take that if statement off and just every time rewrite this file, right? So then you're not allowing your developers to change that behavior. You could add tasks around this that do this part of it instead of it happening every time on the build. You could add like an init or a reinit task that does this extraction. I talked a little bit about determining version, so I'm going to show a little bit of code for that. There we go. So this is our versioning, or kind of a ripoff of the versioning plugin that we've done, and it utilizes the Git library for Java to do a lot of work. So what's really interesting about this is that you can inspect your version control. So you can see things like what are the tags that are previously in line with me, or what's the name of the branch that I'm on. And you can use that information then to drive how Gradle will determine the version. So Gradle knows nothing about this kind of stuff other than it's implemented as part of their system, right? So we're just adding those features to it. There's no API for this. We're just writing our own code that's then going to populate that version property on the project. So here's an example of how we kind of do the reaction too, is that we're going to apply that, we blanket apply this plugin to every project that we run with Gradle, but not all of them are in Git. We still have plenty of projects that are in SVN, or we have other projects that are just totally random things, right? So we can check for what kind of behavior we should apply to this machine, and we can consolidate all those, or to that build, and we can consolidate all those rules. So if we're in some type of Git repository, Git project, which we'll know because there'll be a .git directory, we can apply these rules of how to determine your version using tags and branches. Otherwise, we can bail out and we can use, just look for a version.txt file that simply has, and whatever string is in there, that's what we're going to read in and use as our version. And we won't try to do anything fancy with it at that point. That would be like for our SVN projects. I think some of our guys are adding some more robust SVN features to this right now too. But we also do a couple odd things where, we add an additional action to our build tasks so that anytime you run this build, we're gonna spit out a little bit of metadata in a known location. And that's because we have other tools then that follow on after our Gradle build. Like we use Packer to burn AMIs for Amazon, and we'll suck up this information. We don't want to re-implement how to calculate that version in another tool. We'll just let Gradle do it. So after it does that, it spits it out into this directory along with the name, and then we can just import that. Perhaps it's like we need a JSON input or something like that. Yeah. This Git stuff is a good one that I took from the Nebula guys. There's great examples in there, but I still don't understand how it entirely works. It's that. All right, we'll go back to here. I talked a little bit earlier about applying credentials only when you need them, and this is a problem you'll often run into in that when you're writing a Gradle build or a plugin or something, and you want to do some type of publication, the first thing you do is you configure your publishing block, and you add, here's my repository and here's my credentials for it. And often what you'll do is you'll refer to some Gradle property that you expect, right? And so you on your system, you're testing this, you go into your .gradle, your home .gradle directory, Gradle properties, and you add those in, and then you say, yep, that looks all good, and I send it out to my developers, and then all their builds failed, and they can't even do a Gradle tasks because that property doesn't exist on their system. Well, in that situation, they don't even need it, right? I'm not gonna allow all my developers to publish to our artifact repository, right? That's the responsibility of the CI system upon every commit. That's the only thing that's gonna have the need to even run that part of the task. So we can use parts of the Gradle API to hook into that kind of life cycle and configure those credentials only when they're needed. So on a developer system, they'll never run the publish task. So the publish tasks will never be in this task graph. So from the project, you can access this .gradle property, which kind of gives you more higher level part of your build. And the task graph is actually the calculated set of it's that DAG, that graph of tasks that are going to execute in your build after it's been resolved, right? So you can basically add an action now to that task graph that after Gradle is done configuring that and figuring out exactly what it's all going to need to run, I can say if that task graph has any of these published tasks in it, then I'm gonna iterate over them, and I'm going to configure the credentials on them at that time. So that way, then my developers they don't ever need to have this. Let's see if I can get a pointer over there. No, this is my first time using Keynote in a presentation, so I'm learning entirely about this. So in this scenario, if they don't have that property declared in their build, they're not going to get an error and fail their build out. And you also don't have to have them add some dummy variable, right? I mean, that's one of the things that you see a lot is, yeah, sorry, go ahead, question.
How do you feel about asking the user directly, like on the
Sure. The question was, how do I feel about prompting for input from the user during a build? It's been a long time since I've done that, like actually implemented anything like that. So I don't have a ton of experience doing it. My personal feel about it is that it's probably okay to do. I think the API inside of Gradle is not entirely built around allowing that. One of those guys would probably comment more about it. So it's something that you could do, but I think you might struggle with how that gets implemented because of the way the daemon works and how it does, task execution out on the worker threads and things like that. I'm not exactly sure how that input's going to get passed back, how that streaming is all set up. So you might run into some issues with it if you're trying to run in like a parallel mode or something like that.
Because coming from the PHP world, they use Composer,
Mhm.
and it's something very often used that you have the default setting, and then if you don't have the local setting, it will ask you the question, will provide you the default, you can just hit enter if you want, and you can also override using environment bar, so you can have a non-interactive version and set up like service scripts on the test machine.
Sure. The follow-on comment was saying that in some other tools, there's the concept of you basically declare a variable and that it has this default value, and then at runtime I can prompt you if you want to override that or not and show you what the default is, or I can pass in via an environment variable or a switch or something and say this is explicitly what I want it to be, and then I'm not going to prompt you. Yeah, there's not a full-fledged concept that I know of in Gradle for doing that. You can implement things that are very similar to that, but it's not like a first-class citizen as far as I know for that stuff. I usually go the route of I want the build to be smart enough to figure out where to get those things from. So I usually implement this as if I'm going to need credentials for some stuff, I make it a rule on the team that they have to provide their credentials in a specific format at a specific file location on their machine, like within their home directory, kind of like an SSH key, you know. I know where that's going to be, and my build can just go and serve that up and take it at that point. I think when you start dealing with like input, like providing user input during your build, you're going down the route of kind of dynamically changing how like what your tasks are going to do, and that to me is kind of defeating the purpose of what Gradle is for. While you can implement just kind of arbitrary task execution inside of Gradle, it's the bigger tenets are I want to be able to do a reproducible build, right? And by allowing dynamic input from your user, you're kind of breaking that tenet. That's just my opinion on that. So, good questions though. Bootstrapping build. So how do we actually bootstrap our bootstrap into our projects, right? So that's kind of the difficult thing is I have this Gradle plugin, but now I got to tell my build where to go get this Gradle plugin from, right? If I'm hosting it in some artifact, and there's not a solid answer around this. You can do it like many different ways, but it kind of becomes the whole turtles all the way down the problem, right? So if I need some logic to do that bootstrapping, then how do I get that logic into my build, and so on and so forth. So usually you'll have some type of way of getting a build script block into your Gradle build to tell it where to go get my custom plugin from, and you might have some additional information inside of the settings.gradle file. For that, we often do. We enforce a naming convention. We don't use build.gradle anywhere in any of our builds. We enforce all our projects to name that Gradle file after the same name as the project. And we do that just because as you get into multi-module builds where you have many projects, if someone's in an IDE and they pop up like, oh, open the build.gradle file, they're going to get 7 build.gradle files, and they don't really, now you got to look at the path and you got to figure that out. Whereas if you name it after the project and you know, well, I want to edit the build for this module, I can just, start searching for that module name and I'll get the build.gradle file. There are plenty of tools out there on how to kind of do this, but they're not integrated tightly with Gradle, right? Because you're trying to get that information necessary to bootstrap your Gradle build. The simplest way to do this is you provide a repository, right? That you just clone this out, and that's the start of any project. There's a tool called LazyBones that's out there. It's a templating engine. It's written in Java and Groovy. It uses bin tray as a backend, and you basically can define a project structure here, and you package it up into a zip and put it in bin tray, and then you can you can configure user input. So when you initiate LazyBones and say, create a new project from this template, you can have it ask a bunch of questions about it, like what's the name of it, what's the version of it, kind of that standard, those standard things, and then it can inject that and use that to template out a bunch of files for you. Downside is that you have to, you have to have a bin tray account for that. There's some additional setup. It's yet another project that you have to maintain. Yeoman is another one. It's a templating engine. It's based on Node, but there's Yeoman generators for Java projects, so you could implement a generator in Yeoman for that. Downside, you're going to have Node on your machine, or anyone who's going to do the templating, is going to have to have Node. You could use init scripts in Gradle. So if you don't know about init scripts, the link's here. It's not widely used, but the idea is that you can have a set of scripts in your home directory that Gradle will execute as part of any build. So you could implement kind of this bootstrapping information in there, but you still have the problem then of how do I get that init script onto my developers' machines? Because it's not then part of the build. It's not part of that repository. And lastly, I hadn't really thought about this, but yesterday I was talking to some people and they mentioned that this is how they do it, is they use a customized Gradle distribution, and they use the Gradle Rapper to get that onto your machine. So underneath the hood, the Gradle Rapper is just a small jar that reads in some properties files that includes a URL of where's my zip file that contains Gradle. And so they package up, they take the Gradle distribution and they add in additional init scripts to it, and then they host that themselves, and then they target that URL with all their Gradle wrappers. That's a really clever way of doing it. I'd never really even thought about doing that. Just some downsides to it is that, again, you have to host this binary artifact somewhere. But the biggest one to me is on every version release of Gradle, you have to repackage this thing and send it out, right? So you could get clever and do kind of like proxying and like inject these things in like on the way, so you wouldn't have to like repackage it every time. But so yeah, so lots of possibilities there. All right, we're coming down on time a little bit, but this is actually kind of the really cool piece of code, at least in my opinion. I don't know what you guys will think, but so if I'm a Gradle plugin author for a company and I'm writing plugins that are enforcing these conventions across all my projects, what about my plugin project itself, right? I mean, it's also one of my company's projects, and it also should follow these conventions. So if I'm building my plugin project with Gradle, I should apply these same conventions to it, right? So it's kind of this, chicken and egg problem. My plugin project defines these conventions, but I also need to apply those same conventions to me. And you can do this. It's pretty cool. There's a concept in a Gradle build of a build SRC directory, which is basically a separate Gradle project that gets executed prior to your main build. So it's not a dependency. It's like an inline dependency to your build script, but you can treat it and apply. It's a whole separate Gradle project, so you can apply your own plugins, you can resolve dependencies in it, and all this kind of stuff. So in your build SRC directory, all you do is you put a build.gradle file in there, and then the next time you run your build, you'll see the first thing it will do is execute a bunch of tasks on the build SRC project, and then it will run your main build. But what you can do is you can trick build SRC into thinking that its code is somewhere else, right? So I've broken this up into a couple slides so we can see it a little bit better. But this first block here, ignoring that first if, but the source set block is, for my build SRC project, I'm going to grab the main source set. I'm going to reset its locations of where its source is from being build SRC main Java to be one directory higher. So I'm going to basically look back into my parent project from a nested directory, and I'm going to use the code that's from up there, right? So now my build SRC project and my main Gradle project are building the same code. So I'm going to end up compiling it twice, but these usually aren't huge projects, so it's not that big of a deal. Additionally, I'm going to do the same thing for resources. So basically, I'm just pulling that code down. This little if block about the Jet Gradle plugin and stuff is there because I do all my development in IntelliJ, and IntelliJ doesn't let you do this because it doesn't allow you to have a content root outside of the actual directory of where that module is, which is what we're doing. And so it just kind of, it throws an error. So Basically, this says if I'm resolving this build from IntelliJ, like if IntelliJ is calling in and asking it to resolve this, I'm just going to skip this step. So you kind of you'll lose a little bit of fidelity in the build in that your Gradle files inside of the IDE won't resolve classes if you try to import classes. It'll work, it entirely builds and works, but the IDE just can't see it. The next part here, so after we've done that part and reset those source directories, that would work entirely just fine in your build if you had no extra dependencies, right? You could just run that build then, and you could apply your own plugin name to your build, and it would just work. But if you have additional dependencies, if you're pulling in stuff to your plugins, you need to kind of capture that. You don't want to declare it twice. Well, you could if you wanted to, but this little block basically takes your Gradle file from your parent project, and it evaluates it as a Groovy script against this script holder, and it captures that dependencies block. And then after that, we can replay that dependency block on the project instance inside of build SRC. So we can just capture those dependencies and add them to build SRC. And so now we have this, we're sharing the same dependencies, and I don't have to declare them twice. So if I sure, come on. Oh, it's right here. So here, this is what I'm talking about. Here's my build SRC directory, right? And I have no code here. So I've implemented this same thing. And then in my Gradle plugins here, I'm applying demo.groovy to the project that's creating the demo.groovy plugin, right? So this will, if I switch out to a command line here, Gradle W. I don't know if you guys blow that up. Right, so here we can see build SRC is compiling. Here's kind of that version logic. It's inferring my version off of my Git repository here. And now it's running these code narc tests and stuff, which is all the convention that I defined inside of this plugin itself. But it's doing it on the project itself. So it's kind of a self-building plugin set. So that way, now you don't have some like one-off project in your company that, oh, here's probably some network thing. Right, so now you're just doing it yourself. You're applying your rules to yourself, and you're drinking the Kool-Aid too, and you're right there with the developers themselves. Great, and that is the extent of what I have. Are there any questions? No? Awesome. Well, thank you for sitting here and listening to me ramble for 45 minutes about stuff. If you want to talk to me later, I'm here the rest of the night until tomorrow. So if you want to grab me and talk about any of this stuff or what you're doing at your companies, I'd love to hear from you. So thanks. Enjoy lunch.